Hello friends, welcome to my YouTube channel To The Point. In this video we will learn types of vectors on the basis of their effects. Let's get started. First of all, polar vectors. Vectors having straight line effect are called polar vectors. For example, displacement, acceleration, velocity and force. All these have straight line effect. That's why they are called polar vectors. The next one is axial vectors. Vectors having rotational effect are called axial vectors. For example, angular momentum, angular acceleration, angular velocity and torque. They have rotational effects. That's why they are called axial vectors. Vector addition, geometrical method, triangle law. This is vector A, vector B and vector C. The addition of vector A and vector B is represented by the vector C. C is equal to vector A plus vector B. Parallelogram law. Let's suppose this is parallelogram, vector A, vector B, vector C. This is also vector A, vector B. So the addition of vector A and B is represented by vector C. In the same way, the parallel vector A and B are represented by the vector C. Polygon law. The figure shows us a polygon having 5 sides, 5 vectors A, B, C, D, E. The vector E is represented by the sum of the other 4 vectors A, B, C and D. Commutative property. This figure shows us a vector A and B and C represent their resultant. In the same way, here vector A and B add up and C represent their resultant vector. C is equal to A plus B is equal to B plus A. Therefore, addition of vector obeys commutative law. A plus B is equal to B plus A. Associative property. The vectors obey the associative law shown by this example. Vector A, B, C and D, their diagonal gives the resultant of A plus B. In the same way, this figure shows. Therefore, the vector D is represented by D is equal to vector A plus vector B plus C, or vector A plus into B plus C. Therefore, addition of vectors obey associative law. Subtraction of vector B from vector A is defined as addition of vector minus B to the vector A. For example, vector A minus vector B is equal to vector A plus the negative of vector B, or we can say that the vector B is in opposite direction. Vector addition analytical method. Magnitude of the resultant. This figure shows of the vectors and their angles. Oh, we leave this proof. I'm not doing it here. So next one is the unit vectors. A unit vector is a vector that has magnitude of exactly 1 and drawn in the direction of a given vector. Simply a vector have magnitude. One is called a unit vector. It lacks both dimension and unit. Unit vector have no dimension and unit. Its only purpose is to specify direction. It just specifies the direction in space. Unit vectors. Vectors can be expressed as a product of its magnitude and a unit vector. For example, A may be represented as A is equal to A cap, where A cap shows the unit vector direction. A is the magnitude of A and A cap is a unit vector along the vector A. Cartesian unit vectors show the unit vectors in Cartesian coordinate. You can see vector I in the opposite direction minus I cap, in y direction j, opposite y direction minus j, in the z direction minus k and k. Resolution of vector. It is a process of splitting a vector into two or more vectors in such a way that their combined effect is same as that of the given vector. For example, the vector A is resolved into the two components AN and AT, but their combined effect is same as that vector A. Rectangular components of 3D vectors. If A is a vector, then AX and AY be their rectangular components. Theta is the angle between the vector A and one of its component. The component AY is perpendicular to the component AX. Therefore, the vector A can be written as the sum of its two components, AX that is in I direction and AY that is in J direction. Rectangular components of 2D vector. AY can be written as A sin theta, AX can be written as A cos theta. Magnitude and direction of components. Magnitude is equal to A is equal to under root the square of x direction component and plus the square of y direction component, and the direction is given as theta is equal to tan inverse AY over AX, that are the component of the vector. Rectangular components of the 3D vector. We leave this for the next our upcoming lecture. So friends, subscribe to our channel and hit the bell icon and be part of the conversation. Meet in the next lecture. Allah Hafiz.